Alright, now this one that we're going to do is like the others that we did the last lecture, but the approximation doesn't hold. So we're going to have to use the quadratic formula. So for the first one, I'm going to go through the full workup, but I'm going to move fast because I've already done it out. So pause it if you need to. And then the second one, I'm going to be much more abbreviated because I just don't want to work through every step of the quadratic formula for you twice and have a video that's 20 minutes long when it doesn't have to be. I won't leave anything out. I'm just going to work more quickly on the second problem. So you can see that there's something up here with this tiny concentration that should strike you if you're taking one of my exams. That don't usually see a concentration like that. Hydrofluoric acid has a Ka that is, where is it? 6.80 times 10 to the minus 4. So just looking at these two numbers should tell you that the approximation is not going to hold. But let's do it out. As you can see, it's the 10 to the minus 6 divided by 10 to the minus 4. So that's going to be less than 100. But these are things you should try to look for, but if you're not prepared to do that, that's okay. We'll just keep it in mind that there's a lot of checks and a lot of things that can help you along the way if you're thinking about the problem as you're going along, rather than just doing out every step and only thinking about certain things when you get to that actual step where you do the calculation. Okay, so the approximation is Ca over Ka, so that is 5, or this is the test for the approximation, I should say. 6.80 times 10 to the minus 4, and this comes up to be 0.00825, which is 0.00825 is much less than 100. Approximation does not hold. So that means that we're going to have to use the quadratic formula. Well, that's just how it is. So we got to tough it out. So this x cannot be removed. If we removed it, we'd find that x is a very good portion of this number. It has to be less than it, but it's going to be a large enough portion that if we get rid of it, we'll be way off in our answer. So what we have to do, so we're going to cheat a little bit. We expand this out. We multiply both sides by the denominator. We end up with x squared is equal to 3.82 times 10 to the minus 9 minus 6.80 times 10 to the minus 4x. Rearranging, we get x squared plus 6.80 times 10 to the minus 4. We want to get it into this form, and I'll show you. This form is now ax squared plus bx plus c is equal to 0. If we have that, we have our equation in that form, then we can solve for x using the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Our a is 1. Our b is 6.80 times 10 to the minus 4, and our c is negative 3.82. Don't forget the negative. Well, 2 times 10 to the minus 9. So that's all given up here. So let's, I'm going to have to switch over to a different sheet of paper here. Let me just transfer everything over. Find the problem here. Yeah. So it's negative b. Okay, so x is equal to negative b plus or minus the square root of b squared minus 4a, and a is 1, we can call 1.00, and then minus 3. Actually, we don't even need that, that would be exact anyway, so the 4 is definitely exact, over 2a. Alright, so you can see that we have two answers, or we will get two answers. This number plus this under the square root sign over 2, and then this number minus this term over 2. So we have, so let's break it up. We have x is equal to negative 6.80 times 10 to the minus 4 plus the square root is 1 minus 3.82. Now, a couple of things here I'm looking at. This number is negative, so this term cannot be negative overall. Now the first term here is plus, and then we also have or x is equal to minus 680 times 10 to the minus 4. This type of problem, really all that we're dealing with here is time and kind of endurance to make sure that you don't lose track of things and you don't get bored as you go, which can happen. And just kind of lose track and notice something outside the window, and you have to be focused on this. So these are our two possibilities. This term plus this over 2, this term minus this over 2. Well, look inside. The first thing we have to make sure that's radical, under the radical, that this term is positive. Because if we have the square root of a negative number, we end up with an imaginary term. We can't have that for our concentration. Well, this is positive. This is a negative and a negative. That's positive. So the whole term underneath is positive. That's great. If this was positive, then this term here would have to be less than this one. So just little things to look at. You don't have to worry about it. You can certainly just do the calculation without it. But notice this one here. This term is positive. So this whole square root is positive. This is negative. This is negative. So there's really no reason to go any further with this answer, because we know that it's going to be negative. But and we can't have a negative concentration. But we'll work it all the way through. So this is x for here. This one is 5.50 times 10 to the minus 6 molar. And then, or x is equal to, this one I didn't do out on a piece of paper, I did it on the computer. So this comes up to minus 0.000686 molar. Okay, so these are our two possibilities. Now, what always happens is one is physically possible, one is not. In this case, this one is obviously the one that's physically impossible because we can't have a negative concentration. But you can have times when they're both positive, so then you put them back into our original expression. You can see the one that is positive will be less than this number. So we'll get a positive equilibrium concentration. If both of these terms are positive and you put them in, one of them is going to turn out to be larger than this number, so the equilibrium concentration would be negative. So only one of these values will work. If you spot one that obviously won't work because it's negative, get rid of it. If they're both positive, you'll have to wait until you get through with both calculations and then go back to the ICE table and figure out which one won't work. So at equilibrium, we have, just write in these, we have the HA is 5.61 times 10 to the minus 6 minus x, so it's going to be minus 5.550 times 10 to the minus 6 molar. And then we've determined x, so this is the concentration of H3O plus and the concentration of A minus. So we have our answers for those. This one turns out to be 1.10 times 10 to the minus 7 molar. And then also pH, which is going to be negative log of 5.50 times 10 to the minus 6, or 5.2. So a lot of work there, but that's how it is when you have to use the quadratic formula. So let's go on to the second one. Second problem here. And move a little bit faster. So we have HA plus water goes to H3O plus A minus. We have 1.16 times 10 to the minus 4 molar, 0, 0, minus x plus x plus x. Should be pretty standard by now. Shouldn't be anything that throws you off when I do that. Should be way ahead of me, actually, especially my younger students should be already done. They move so fast compared to me. Ka for nitrous acid is 4.5 times 10 to the minus 4. The approximation is 1.16 times 10 to the minus 4 over 4.5 times 10 to the minus 4 is 0.258. 0.258 is less than 100, so approximation doesn't hold again. So we have to work it out. So I'm going to take this and put it into the final form. That's x squared plus and so A is equal to 1, B is equal to 4.50 times 10 to the minus 4, and C is equal to minus 5.22 times 10 to the minus 8. And these go into the quadratic formula as so x is going to be negative b plus or minus the square root of b squared minus 4ac over 2a, so that's going to be negative b, 4.50 times 10 to the minus 4, plus or minus the square root, I don't know if I saved myself enough room, let's go down here, negative 4.50 times 10 to the minus 4, plus or minus the square root of b squared, minus 4a, a is 1, b is, or c is negative 5.22 times 10 to the minus 8. Those two negatives are really nice to see because then we know that this whole thing is going to be positive. If this was positive, then we just have to hope that this term was less than this one. If it's not, if you ended up with a negative term under here, you have to start over again. You got to find out what, and you have to go back and figure out what happened. Okay, now this one I'm going to put into my computer just to double check. So it's going to take just a little bit here, but I want to make sure that because I didn't double check it before. So real quick, we have 4.5 times 10 to the minus 4, and let's see, yeah, okay. So if you work this out, I'm going to let you do that because now it's just a matter of getting the numbers, the two different numbers, and we have x will equal either 9.60 times 10 to the minus 5 molar, or x will equal negative 5.46 times 10 to the minus 4 molar. From the looks of it, yeah. Well, this is negative. It can't be the answer. This has to be the answer. So when we put this number back up here, we got to hope that, and it looks like it. It looks like it should still be positive once we put it in there. We have to have a positive concentration. So the end result then is we end up with the concentration of H3O plus is equal to the concentration of A minus, which is equal to 9.60 times 10 to the minus 5 molar. The concentration of the acid at equilibrium, the full acid, is 1.16 times 10 to the minus 4 molar minus 9.60 times 10 to the minus 5 molar, which is equal to 2.00 times 10 to the minus 5 molar. You can see the substantial difference, and that's why we couldn't use the approximation. And then pH is going to be the negative log of 9.60 times 10 to the minus 5, or 4.01.